The slope is the steepness of a line and can be calculated if 2 points along the line are known. So the slope is equal to the change in y over the change in x, which is commonly known also as rise over run. So what does that mean? Well, the vertical distance between the y points is also known as the rise or the change in y. So we're moving from this y value to this y value. That distance is how much we are rising. The horizontal distance between the x points is known as the run or change in x, the delta x also. So the run is how far our x point here is from our x point here. That's the horizontal distance. And again, together, the change in y over the change in x gives us the steepness of the line, which is also known as the slope. The change in y is the same as subtracting the first y value from the second, the first x value from the second, or vice versa. If the second point is above the first point, then the slope will be positive. By second point, I mean if you're looking at the coordinate plane from left to right, the second point is the one furthest to the right. So since this point is above the first point here, that's how we know this slope here is positive. If it's going the opposite direction, if the second point is below the first point, then the slope will be negative. Upward sloping positive, downward sloping negative. A few unique cases are a completely vertical line and a completely horizontal line. If a line is completely vertical, that means it is all rise, change in y, but no run. There's no change in x. It's the same x value for all of these points. Anything divided by 0 is undefined. That is why a vertical line has a slope that is undefined, since there is no change in x. A horizontal line has a slope of 0 since there is no change in y. So this is all run. All of these x values are changing. But it's the same y value, so there's no change in y. 0 divided by anything is 0. Let's walk through how to calculate the slope of a line if we are given 2 points on that line. Step 1. Subtract the second y coordinate from the first y coordinate. Again, I'm considering the second coordinate the one furthest to the right. The first point is one to the left. The second one is the one furthest to the right. But I'll also calculate the slope using this one first and this one second. And you'll see that the answer will wind up being the same. So subtract the second y coordinate from the first y coordinate. So it's -5 minus 5. That's our change in y, which will give us -10. And if we look, if we're going from -5 up to +5, from -5 to the x-axis would be 5. From here to +5 would be another 5, so it'd be a distance of 10. Step 2, subtract the second x-coordinate from the first x-coordinate. So our first x-coordinate is -3, minus the second x-coordinate, which is 4, which that gives us -7. And then step 3, divide the change in y by the change in x. A negative divided by a negative becomes positive. So the answer is 10/7. That would be the slope of this line. Now when doing this, I considered this our first point and this our second point. As I mentioned, if you use the point furthest to the right as your first point and the one to the left as your second, you'll wind up with the same overall slope. You would get 5 minus -5, minus a negative would be positive, and you get 4 minus -3, minus a negative would turn this into a positive, so 4 plus 3 would be 7. So you'd still wind up with 10/7. As long as you use these together and these together, the final slope will be exactly the same. Let's have you try a few practice questions. Find the slope of each line. Question number 1 is this green line. -2, 5 is this point here. And +3, 2 is the point here. Question number 2, the blue one. -3, 2, and 2, -4. In question number 3, purple, -6, 0 is this point, and +1, 4 is this point. Pause the video, find the slope of each of these lines, and then press play when you are ready to begin. So for each of these, our first point will be the one furthest to the left, and our second point will be the point furthest to the right. So question number 1, step 1, subtract the second y-coordinate from the first y-coordinate. So that would be 5 minus 2 in our numerator, which gives us +3. Step 2, subtract the second x-coordinate from the first x-coordinate. So that gives us -2 minus 3, which gives us -5. And now step 3, divide the change in y by the change in x. 3 divided by -5 gives us -3/5. And we see this line is downward slanting. The second point is below the first point. So we know this slope was supposed to be negative. Question number 2. The 2 points we had were -3, 2 and 2, -4. Step 1, subtract the second y-coordinate from the first y-coordinate. That gives you 2 minus -4. Minus a negative turns it into addition. 2 plus 4 equals 6. The distance between +2 and -4 has a total distance of 6. Step 2, subtract the second x-coordinate from the first x-coordinate. That gives you -3 minus 2, which is -5 in the denominator. Step 3, divide the change in y by the change in x. 6 divided by -5 gives us -6/5. And again, our second point is below the first point, so this slope was supposed to be negative. Question number 3, we had the 2 points -6, 0 and 1, 4. Step 1, subtract the second y-coordinate from the first y-coordinate. That gives us 0 minus 4, which is -4 in the numerator. Step 2, subtract the second x-coordinate from the first x-coordinate. So we're subtracting 1 from -6. -6 minus 1 gives us -7. We divide a negative by a negative, we wind up with a positive. So step 3, we divide the change in y by the change in x. We get +4/7. The second point is above the first point, so this line does have a positive slope, as we were expecting.